So yes. Okay. So yeah. So we'll start with today's class. That is with a fresh chapter, a new chapter. That is on engineering materials. Right. So engineering materials. So here anything that is any object that has been present in this world, okay, physically present, okay, has to have some, it has to be made up of some material, right? There is nothing in this world which does not have which is not been made up of a material. It does consist some material on which it is been made up of, right? So basically these materials can be classified as into generally these four categories, that is metals, then ceramics, polymers, okay, then it can be classified as composites also, right? So generally any of these things will generally fall into this, where we are restricted only for engineering materials, excuse me, we are considered with engineering materials, okay, right? So those engineering materials can be classified into these four groups, right? So there are these things that come into picture, right? Okay. So yes, now let us go to metals, where predominantly most of the things that we come across in our day-to-day life, okay, is generally many of these things we generally come across things made up of metals. So these metals can be further classified as ferrous materials or non-ferrous materials. Okay, so they can be classified as ferrous materials or non-ferrous materials, right? So what is this ferrous materials and non-ferrous materials? So as we have already studied in the school, okay, where these ferrous materials predominantly consists of the iron content in it. The major uh, portion of it is generally made up of the iron itself. Okay, so that is more predominantly that has been available, and it is being used in many applications, right? Okay, so thereby all these metals generally they have certain properties, where these metals have are generally good conductors of electricity and heat, right? Okay, and they are solid in nature, right? And that is at room temperature, okay, and they are malleable and ductile. So at least any one of them, at least they will be, right? So freshly cut material surfaces are lustrous, that is they'll have a shiny surface and all those things, okay, and they're exposed to the atmospheric air, where they can get corroded, where they may change the color slightly, right? So when there are the other forms where they produce sound, typical metallic sound, okay, and most of the materials we will see what about the forms of alloys in the later case, right? So let us see about the ferrous materials. Ferrous materials, as informed, like it is predominantly made up of iron content in it, okay, major constant is iron, okay, major constant content is iron, right? Okay, so then they are called as ferrous materials. If the iron content is not present in the metal, then they fall under the category of non-ferrous materials, okay. But in this ferrous materials itself, there are different categories, that is there are, it can be further uh, distinguished, okay, by having as because they have different properties, okay. There's a slight change in some of their constituents, that is in the ferrous content, okay. So because of that, their properties drastically change. So what are those? Let us see that, okay. So they are nothing but, so one of them is called as low carbon steel, okay, low carbon steel or mild steels, okay. This iron has got the capacity to absorb carbon that is present in the atmosphere, okay. So what will happen is they start, though we are not going to impose any kind of carbon in it, okay, they will absorb this carbon content from the atmosphere when it is being heated up to red hot temperature, and once they are cooling down, once it has been cooled down to become solidify, okay, so during that time they will absorb the carbon content naturally from the atmosphere. Okay, so thereby carbon is an is one of the things that is going to be present in the iron itself. So if the carbon content is going to be present from 0.15% to 0.25%, okay, then they are going to be called as low carbon steels, okay, where this will behave like, okay, they will behave like they're moderately strong, okay, and good weldability. They, you can use them for welding, okay, very easily. Okay, if the carbon content of present in the iron is only within this range, okay, then they are moderately strong, not very strong, moderately strong, okay, and they have got very good welding properties. They weld with another material, with another mild steel very easily, and their bonds are very strong. Okay, so this is how, this is one of the properties of this mild steel or the low carbon steel. The second thing with this is that we can easily, it is easily malleable and ductile, okay, as well as when it has been exposed to air, okay, and they're easily, they will change their color, where they become from dark gray color of iron content to the brownish color, where the surface gets corroded because of the contents present in the atmosphere, so they will lose their iron content. So whatever the iron that is present, they will immediately get converted into ferrous oxide or ferric oxide. Okay, so that is why they change their color. So where it starts to degrade, that is, they start to get corroded, right? So that is, they have very low corrosion resistance properties. Okay, right? So that is how is the low carbon steel will behave. Then coming to medium carbon steel. So in this, the only content is iron, and about 0.3% to 0.6% carbon will be present in this. So if we are going to add up this, then what is going to happen, right? So there will be, we cannot assume that there will be only a small change. There's a very drastic change just because of this small change in the percentage itself, right? In the percentage itself of the small quantity. So they, the strength of this material is going to be very high. They are not going to be like the low carbon steel. They are going to be much more stronger. Okay, they can be welded still comparatively less with compared to low carbon steel. Okay, right? And this mild carbon steel, as I mentioned, they will not get corroded that quickly as low carbon steel. So these have much more corrosion resistance properties. Okay, right? So this is generally used in rollers, screws, okay, axles, crankshaft. All these are made up of the medium carbon steels. Okay, right? So because of the, what is the thing that we have to see here from another angle is that uh, if we change some of these properties, okay, then they, I mean, sorry, if the contents, the chemical contents, okay, then their properties are going to be varied. What are their properties that can be varied is what we have to have an idea. So based upon the properties, how they are going to behave, then based on that, we can decide, okay, in which application can we use this particular material. Okay, so unless and until we know the properties of that particular material, it is not easy for us to decide where can we use this particular material, for which application can we use, right? So coming to the properties for general uh, perception, okay, for an overview, if we take up, okay, right, we can take up, say, for example, one is what is the corrosion resistance that the material has, right? How quickly does it get corroded, or how long does it take time to get corroded, right? This is one of the major properties. Then the next one is wear resistance. Now, if the material is going to be rubbed on another material, so what is going to happen to the, to this particular metal? So is it going to be worn out? Okay, or it is not going to get worn out? How fast does it get worn out? Right? How fast does it get worn out? So all these things matters over here in the wear resistance, because only then suitably we can see whether in which application can we use. So if it is going to be more wear resistance, then we can use it in parts where there is more of physical movement between the parts, right? Where there is movement, that is like a piston that is sliding continuously, right? So then in that particular case, we cannot have a material, we cannot choose a material which has got very low wear resistance. It has to be highly wear resistant, so it does not get worn out when it is being sliding, right? So thereby wear resistance is another property. The next thing is, what is the hardness of the material, how strong it is, right? That is also equally important, right? So it has to be hard enough, right? Otherwise, if it is soft enough, like say for example, for our simple understanding, if it is like a bubble gum, then it's of no use. It may be more resistance, wear resistance, but it is going to be very, very soft. Then it's going to become very difficult to find out the applications in which place can we use such material. So hardness comes into picture. What is the hardness of the material, how hard it is? Now for our simple understanding, if we know, we have seen aluminium and we have seen iron. So aluminium is quite soft material, iron is quite hard material, right? So we cannot use aluminium in every place. There's certain limitations for that, right? So the hardness also is an important property of the material. Then the next thing is whether it is going to be elastic in nature or ductile in nature, right? So that is also another property that we have to see, right? So based on all these things only, the application will be used. Okay, in the application we can use only such particular material which will meet the required properties, which will meet the desired properties. Okay, right? So next, coming to high carbon steel. Okay, now in this only iron is going to be there, plus apart from that, it will have 0.6 to 1.5% of carbon present in it, right? So if we look here, it is going to be, it started with 0.15 to 0.25, then 0.3 to 0.6% of carbon, and now in high carbon steel it is going to be 0.6 to 1.5% carbon. So this type of carbon steel, okay, will have very high hardness. It is going to be very, very hard and very tough material, right? Both because of the carbon content. Carbon is a very hard material. Okay, just like diamonds, they're predominantly made up of carbon, so it's a very hard metal. So the this much amount of carbon is enough to change the property of the iron itself. So they're going to be very hard, very tough, very high resistance in corrosion also. Wear resistance is also going to be high. Their weldability will be very, very poor. We cannot weld this type of iron. They will not bond with good strong joints. Okay, so because of the carbon content, high carbon content present in this particular material, they will not be, we cannot use such types of materials for welding. Welding quality will be very poor. So they use this in rolling mills, where you see in the industries they will have large rolling mills, and steel balls they will use, right? Rope wires, screwdrivers, all these are made up of high carbon steel, because they have to be really hard when they are going to use this. It should not be soft, and it should not bend or something or break away when it is being used. So only in such applications they will use high carbon steels. Yes. So the next type of the way the iron can be classified is that this iron can be classified by again in the form of carbon content itself, but having different properties. So one of them we call it as the cast iron, where this cast iron that we have already studied in the 11th or 12th standard, extracting the iron ore and so on. So predominantly we get the pig iron, the wrought iron, and the cast iron. So this cast iron can be further classified into gray cast iron and white cast iron, right? So the cast iron is basically, what does it have? When we get the when we extract the iron from the ore, okay, we will have about 2 to 4% of carbon in it naturally present. Okay, so but this type of iron will be, cast iron is very, very brittle material. Okay, it is very hard. Okay, density is high. Okay, at the same time it is going to be very brittle because of its high carbon content. Now if you look at this, it has got about 2 to 4% of carbon when compared to 0.6 to 1.5% of carbon. So this is much more higher than the high carbon steel. So this is going to be the cast iron, where it is going to be very brittle. So the moment it is going to fall onto the ground, from a particular height, it is going to break away into pieces, right? That is why we will have to handle cast iron, okay, carefully, right? Because of its brittle nature. So gray cast iron and white cast iron, this is nothing but a small change in the carbon present in it, okay? But because of this, the color of the cast iron will also vary, okay? The color of the cast iron will also vary. So in gray cast iron, we'll have 1.5 to 4.3% of carbon, okay, and a small quantity of silicon also, because it is not the pure form of iron, okay. And this has got an high compressive strength. So the more we compress on this material is not going to decrease its height, or it is not, we cannot compress it so easily. It is going to be very hard. So it is, when we apply a compressive force, okay, then it is not going to get compressed at all, right? So that is the compression strength, okay, right? So it is, even now it is used in making engine blocks, okay, pumps, okay, valves, flywheels, and so many other, in so many other applications. Of course, nowadays what we are seeing in the uh, two-wheelers and four-wheelers and all, the engines are not made up of iron, but even now the in the high-end engines, that is the where mm, especially for the railway diesel engines. Those engines, the piston, connecting rod, crankshaft, right, the engine body or cylinder, everything is made up of cast iron only, not of aluminium. But due to technology advancements in two-wheelers and all those things, they've replaced this with the aluminium alloys. We'll see that later on. Okay, but previously all the engines are made up of cast iron only. Right. So white cast iron, yes. So this white cast iron will not have a grayish color. Okay, they will have almost a fair whitish color, almost like aluminium only. Not exactly aluminium. The look will not be so as much. It will be much more brighter color. It will not be a dark iron in gray color. Okay, so that is why this name white cast iron appears, and this is because of its lower carbon percentage. It has got a carbon percentage of 2.5% and 0.8 to 1 to 1.2% of silicon, right? So here, because of this, what is going to happen is this type of cast iron is going to be difficult to be machined, okay, and it is going to be abrasion resistance, nothing but wear resistance. Okay, it has got very high wear resistance, right? So this is used for the car wheels, right? Then the crushing grains and all those things. So car wheels, nothing but nowadays we have alloy wheels. So previously, the ambassador cars, the wheels for that and all those things, the wheels, the rims of that were made up of this white cast iron, right? So they had these properties where it has to have high strength as well as wear resistance also. So they're used to use this white cast iron, right? Okay, so this is about some of the classifications that we have with respect to the ferrous materials. Okay, so this is about the ferrous materials. So all we have to remember over here is about the percentage of carbon and what are the major changes in their properties. Of course, there are many more large changes of the in the properties in their mechanical properties based on their chemical composition, but we need to know some of the basic things over here. Okay, right. So next we shall go to aluminium. Okay, so sorry, the non-ferrous materials. So non-ferrous metals. Okay, non-ferrous metals where these metals don't have any iron content in it. Okay, so as we all know, we can say about aluminium, magnesium, zinc, right? All these are non-ferrous materials where they don't contain any iron content in its pure form, right? So taking up about the aluminium, it is a silver material. Okay, looks very shiny in physical appearance. Okay, quite soft in nature. Okay, and its hardness is also low when compared to, excuse me, when compared to iron, right? Okay, So aluminium, pure form of aluminium has these particular properties. Okay, but these aluminium are having good corrosion resistance. They are light in weight. They are not heavy. Okay, that is their density is low when compared to iron. Okay, good thermal resistance. Sorry, thermal conductivity and electrical conductivity. Because of this reason only, we see that our electrical lines, okay, the wires are made up of aluminium because of this particular property, whereas we don't have this particular property in iron, right? So thereby we use generally aluminium wires for electrical power transmissions, right? So nowadays they use for applications, pistons are made up of actually aluminium alloys, not pure aluminium. Aluminium alloys, connecting rods are also made up of aluminium alloys. We'll see what is an alloy later on. Okay, transmission lines, cooking utensils, okay, and some particular portions are also made, I mean particular parts are also made used in the marine applications, which are majorly made up of aluminium, right? So the next major thing that we'll be seeing is the copper, right? So copper, yes, that is also got a very good thermal conductivity as well as electrical conductivity, right? It does not have a high melting point as compared to that of iron, right? So they're comparatively lesser melting point. Okay, and this copper is generally used for the electrical and heating purposes. So because of this reason only, copper tubes are used in the refrigeration and air conditioning system. So if you look at any AC or even uh, the pipes carrying the refrigerant in the refrigeration system, these pipes will be made up of copper, not of any other material, because of its property, that is the it has got very good thermal conductivity and electrical conductivity. Majorly we use this in refrigeration and air conditioning system is because of its thermal conductivity, that is it can absorb heat very quickly and it can give out that heat to the other system or to the atmosphere very quickly. So there's a very fast heat exchange when we use copper materials. So that is the reason why all these tubes will be made use of copper. But whereas if you replace this by aluminium, since it is cheaply available, soft in nature, lightweight, and all those things, then the efficiency of the refrigeration system will come down because they are not that good thermal conductors, right? Okay, so based on the properties of the material only, that particular material will be chosen for a particular application, right? So next, coming to uh, apart from this, we have nickel material also, where nickel is another non-ferrous metal, where it is much more harder and stronger than steel or iron, right? So, and it has also got high resistance to wear and high resistance to corrosion also, right? So that is also another non-ferrous material, sorry, metal that is used in many applications, right? Okay. So now let us move on to what is an alloy. Now, an alloy is actually uh, the mixture of two or more materials, okay, combined together, right? They are going to mix two or more materials, okay, together. It's especially metals only, okay. It can be a ferrous metal, it can be a non-ferrous material. All of them put together, okay, we can have an alloy. So, what are the general alloys that we will be able to see that we already know is brass, consisting of copper and zinc. It is an alloy. Brass is an alloy, not it is a non-ferrous alloy. Okay, majorly consisting of copper and zinc, right? So zinc with up to 50%. So the other remaining portion with the copper, right? So ductility increases once we add up this. We get up to 37% increase in its ductile nature. Okay, so that we can get. Okay, and zinc beyond which its ductility falls. Okay, lead and tin are imparts of other properties of brass. So there are various standards used in brass itself, but major constant will be copper and zinc. Okay, so major material will be copper and zinc. So now when we go for bronze, bronze is made up of copper and silicon. Okay, copper is made up of copper, sorry, bronze is made up of copper and silicon. Okay, where what will happen is it will have about 88% of copper, 10% silicon, okay, and 2% zinc if at all, if it is required. Majorly, once we say it is only bronze, it is by this. Maybe we can add up a third material which is a zinc also, right? But still the major constant is only the copper and silicon. Okay, so thereby we will be having the bronze only as this, right? So in this we can have different, what is happening in these alloys is that the moment when we add these two materials to form an alloy, it is going to imbibe the properties of copper as well as silicon. So one end, if you see, copper has got good thermal conductivity uh, and heat. I mean, sorry, thermal and electrical conductivity. And on to the other end, silicon has got good wear resistance properties, right? So in bronze, we can see both of them, right? But of course, since bronze, we cannot exceed the properties of copper because we have only a portion of copper in the bronze alloy, right? So thereby, but it will have the nature of all the materials that has been combinedly put to form a particular alloy, right? So it will have all those characteristics, and it all depends upon the quantity of the different materials that is being used, different materials that is being used. So depending upon the percentage that is being added up to form the alloy, the properties will vary. That is the hardness, the conductivity, corrosion, and all this will vary. Now, if you look at this, okay, so bronze majorly used for casting guns, boiler fittings, right? So many of the things, so the boiler accessories, so okay, so those are all made up of this bronze materials, okay, bushes and all those things. So why they are being used is because their nature is like this. They are a little bit soft, they are easily malleable and ductile in nature, good conductor of heat and electricity. So because of this property only, they are being used in boiler fitting so that they conduct the heat, right? If we use, instead of this, if we use iron or anything else, what will happen is iron is prone to corrosion, right? It will get corroded easily, first thing. Second thing, they are not that good conductors of heat and electricity, so they cannot be usually preferred in boilers, right? So based on this properties only, the material is been selected. So apart from this, electrical wires, not exactly actually. Plumbing fittings, yes, they use this. And in refrigeration and air conditioning, not majorly used for bushes and other things and all those things. They will use this for which I mean made up of materials made up of bronze, right? So like this, we have many other different types of alloys also. Now, if we take about say aluminium, okay. Now, if I take about aluminium, the alloys of aluminium, okay, one which we know, okay, the one which we know that we have already studied is duralumin, duralumin, okay, right? It's an alloy of aluminium, right? And similarly, we have so many other aluminium alloys, like we have aluminium 2021, then we have aluminium 6061, then we have several series of aluminium is there, then we have aluminium 7025, right? Then there are other standards where we have LM6, right? That is light metal series 6. Then we have LM25, right? So like this, all these are all alloys of aluminium. So what is going to be there in this duralumin, the application? This is the most preferred alloy in making aircrafts. They don't prefer only aluminium or aluminium 2021 or 6061. No, duralumin is the most preferred. That is because they have the properties required for making aircraft. So what is going to happen in all these things is that their constituents will vary. So majorly it will be made up of aluminium, okay, and then they will have some percentage of copper, right, some percentage of zinc, right. Now if I take up, say for example, if I take up aluminum 6061 or 7025, okay, it will have major constituent as aluminium, Then the next thing will be major constant. After that, after aluminium will be zinc, right? And then some constant of about say for example a smaller quantity of what can we say, tin. Okay, tin can also be there, right? So like that, the different combination of metals and non-metals are being made to form the alloys. So because of this variation, the properties will vary, right? So based on that, then for this particular alloy, they will see what is the uh, hardness, tensile properties, ductile properties, compression strength, right, corrosion resistance, right, all these things, and based on those values, the application can be decided, right. So this is all about the alloys. So there are n number of ferrous metals. That is, we have aluminum, magnesium, zinc, copper, right, and all those things. Similarly, when we come to alloys, we have many number of alloys. We have aluminum alloys. We have n number of aluminum alloys. Okay, there's a very big long list. Okay, and similarly for copper also there are copper alloys, right? It's not just restricted to brass and bronze. There are many more copper alloys, right? Then similarly we have zinc alloys, right? Magnesium alloys, nickel alloys. So many things are there. So alloys are an endless list because it's like because we are combining so many metals together to form an alloy, right? So the list is an endless one. It's a very long list. Okay, we shall at least know some of the basic things like brass, bronze, right? And what is duralumin, like, and so on. Okay, what are the alloys of copper? So copper alloys will be basically brass, bronze. Okay, like this. Okay, right. So yes, so this is some view about uh, the uh, um, the metals, non-metals, and a few insights about the alloys. Okay.